This is a Core 2 revision lesson for trig and arcs and sectors. The trig I'll be covering today is the sine and the cosine rule and the area of a triangle formula. And we'll start with just the sine rule. The sine rule is one of the ones you've actually got to remember. It's A over sine A, B over sine B, C over sine C. The trick with these being that the angle and the side must be opposite each other. So you'd start by sort of labelling things. Lovely formula here that can be used upside down as well, that if you want to find out an angle, you can just put the sine A on the top, the sine B on the top. And this is, I say, one of the ones that's not in the formula book, so this is something you need to remember. There's going to be 5 formulas today, and this is the first one that you've actually got to try to remember. I'm going to try and use it with an example here, and it just says find out the length L. And you'll notice the pattern here that we've got L and we've got the side opposite. We've got 10 and we've got the side, the angle opposite it. So we can write L divided by the sine of 41 equals the other side divided by the sine of 34. To work out what the length L is, we're just going to times by sine 41 up here. Let's times that up there. And there's your L. L equals 10 divided by sine 34 times by sine 41. And when you tap all of that into the calculator, you end up getting, let's go back one. Type all of that into the calculator. Do check that you get 11.73. 11.73. I'll go on and do another one as well. Do pause this at any time if you want to try it yourself. Try pausing that now. We want to try and find out the angle. So this time I'm going to use my formula upside down. I'm going to say sine A over its opposite side, which is 45, equals sine 23 over the one that's opposite it, 38. Rearranging this time takes 2 things. First of all, I've got to times up here by the 45, times that by 45, brings that up there. Tap all that into the calculator, and to find out what A is, to get rid of this sign, we're going to end up doing an inverse sign. And the inverse sign of that, when you tap that into the calculator, should give you the inverse sign of 0.463, which gives 27.6. Try that yourself now, check that you do get the same thing. Well, there's the sine rule. This one's the longer one, the cosine rule. A squared equals b squared plus c squared minus 2bc cos A. And this is actually given to you in the formula book. It's worth trying to remember it, but it is there if you need it. The rearrangement isn't. So trying to find out angles, you're either going to have to learn this rearranged formula, and that's sort of you add this over this side, take this off here, and then divide by the 2bc. Either learn that, or as I'll do in the example in a minute, just rearrange it once you put the numbers in. That's an example for the cosine rule then. I mean, one of the things is to spot when you're going to use it. And the cosine rule is always used when you've got 2 sides and the angle between them. 2 sides and the angle between them, you want to find out the other side. 2 sides and the angle between them, and you want to find out the other side. It's always the same sort of pattern in these cosine rule ones. So here we go, an example. Notice here I've got the 2 sides and the angle between them. And so if I'm trying to work out what this is, I mean, the first thing to do would be to write down the formula. A squared equals b squared plus c squared minus 2bc cos A. Now we stick the numbers in. This is what we're trying to find out. 5 squared, add 12 squared, minus 2 times 5 times 12 cos A. You work these 2 bits out separately. There's the 25, there's the 144, and this is minus 120 cos A's. I've seen some of the students with lower grades sort of trying to add up this first of all. It's not. It's 25 add 144 minus 120 cos A. What was A? It's 43. Stick the 43 in there. When you tap all of this into the calculator, you then got to remember that this is L squared. So square root it, and that will give you the L, what L is. What L is. Let's go back a bit to see if I've got the answer. Oh, I have got the answer there. 9.02. The answer to that one there, 9.02. You can check you've got it. I'm going to find the angle. As I said before, either remember the formula or let's try and put these numbers in ourselves. The important one is that the A1 must be opposite the angle you're trying to find. That one's A. These two can be the other way round, either way round you like. They're just going to be 9 and 16 here. And so just putting this into my formula, I've got 11 squared, I've got 9 squared here, 16 squared here, 2, 9, 16, and there's the cos of A that I'm trying to find. I'm working these things out. I'm working out all of this. I've done 121, take away 81, take away 256 to get that bit there. My next line now I'm going to do divide by 288, gives me cos A. This actually works out to be minus a quarter. And when you do the inverse cos of minus a quarter, and when you do the inverse cos of a quarter, you get 41.4 degrees. If you want to do some practice of those, here's a sheet that you could look at. Just pause now and try these. And continuing, move that out of the way again. Here's another sheet here where you can actually use the cosine rule to try and do a couple of them as well. The third of the formulas is the area of a triangle formula, and although many people do remember this half AB sine C, I don't really teach it like that. I teach it as it's a half one side times the other times the angle between them. And again, it must be the angle between them. Half one side times the other times the angle between them. Or it could even be over here. This side times the angle between them. The formula, sort of letters in the formula are irrelevant really. It's just one side times the other times the angle between them. Just one quick example there if you wanted to see it. It really is just timesing it. Half times by 7 times by 9 times the sine of 39 degrees. You can check for yourself, you get 26.4. Exercise, push pause if you want to try it. The final bit is looking at the circles, and part of the circle around the outside, you'll remember from GCSE, around the outside of the circle is called its circumference, and the distance around the outside, the circumference is equal to 2 times pi times the radius of the circle. Now at A-level we're never looking to go all the way around, we're quite often looking at trying to find a small part of it. Now if I went halfway round, then I'd just want my arc length would be equal to a half of 2 pi r. If I just went a quarter of the way round, then I'd want a quarter of 2 pi r. If instead I wanted to go a smaller bit, say I looked at this bit here, and I want to know this is 42 degrees, then the fraction I'd be looking at here is 42 out of 360 times by 2 pi r, or as a formula, theta angle out of 360 times by 2 pi r. Now the beauty of our course is that we then actually start talking about radians instead, and instead of having 42 degrees here, we could have an angle in radians. Now if my angle's in radians, then this 360 changes to a 2 pi times by 2 pi r, and this is where the lovely bit happens, that the 2 pi here and the 2 pi here cancel out, and you get the shortest formula around is that the arc length is just equal to theta times by r. That's where that formula comes from. The arc length is just times by the angle in radians times by the radius. Well, the great thing is that this works, or there's an exercise you could try some, but the great thing is that this works for the area as well. And if I'm on a GCSE one and I'm trying to find out the area of a sector, and again I had 42 degrees in there, then I'm looking at the area of the circle, which is pi r squared, and I'm doing 42 over 360 times it. Because I'm in radians, I'm doing theta over 2 pi times by pi r squared. And again, these pi's cancel, leaving us with a half, because the 2's on the bottom, r squared theta. Here's that formula there, a half r squared theta. There's the 5 formulas that you need then, and in the next recording I'm going to do some exam questions using those ideas.